Today I'll be talking about the binomial probability formula and how to solve a question using that formula. So first off, the binomial probability formula goes like this. This right here is just a combination. N is the number of trials. P equals the probability of success. And then Q, in fact, equals 1 minus P. So it's equal to the probability of failure. And so what binomial specifically means is it means bi means 2. And so you'll know when to use the binomial probability formula because it will either be a success or a failure, as we'll illustrate in the next problem. And so the question goes, a study in June 2004 by the Nevada Department of Transportation concluded that 74% of front seat occupants use seatbelts. A sample of 10 vehicles is selected. What is the probability that the front seat occupants in at least 7 of the 10 vehicles are wearing seatbelts? So first we have to find out our important information. And so the number of trials is 10. There are 10 people that participate in the seat occupants. The probability of success of wearing the seatbelt, in other words, was 74. And then the probability of failure would just be 1 minus 0.74, which is equal to 0.26. So now that we have the information right here, we can move on. And I'm just going to erase to get some space. So the question asks, what is the probability of at least 7 out of 10, which could be written like probability of x is greater than or equal to 7 given n equals 10, which would be similar to the probability that 7 seat occupants are wearing seatbelts, or the probability that 8 seat occupants are wearing seatbelts, or so on. Plus is just another way of saying or. And so from that point, we can go to actually going to the combination, the binomial probability formula, and using it to solve the problem. So of course there's going to be 4 parts, like we illustrated. The first one is the probability of 7 seat occupants wearing seatbelts, which would equal, see? It would be out of 10 seat occupants in total, but we're choosing 7, and then the probability would be 0.74. This is the probability of success, which would be 7 to the power of 7. Probability of failure, 10 minus 7 equals 3. And that's just and then for this one, we do the same thing, just switching the x value. The x value is this one right here. Now it would be 8. Again, 8. And then 1, 2, 6. 10 minus 8, 2. We just have 2 more. Out of 10, we are choosing 9 successes. So the success rate times those to the power of those 9 successes. And our last one, out of 10 end up, the total number of occupants end up wearing their seatbelts. So the probability of failure would be 0. 10 minus 10, 0. So when we do these, I already have the calculations. First one would be 0.25625. Next one would be 0.27353. Third one would be 0.173005. And the last one would be 0.049240. And it makes sense that the last one is the least probable with the 0.0 before, because it would have to be a 100% success rate. And so now we just add these up, and we get a total of 0.752065. And one way to write this using words could be, there is a 75.2065% that at least 7 of the 10 seat occupants are in fact wearing seatbelts. So the summary is, when you see a problem with a success, such as wearing a seatbelt, and a failure, such as not wearing a seatbelt, that's 2. And it's either one or the other. That's how you know to use the binomial probability formula, because again, bi means 2. Then you just use the formula, the combination, you plug it in, at least 7, or, which means it could also be 8, 9, or 10, and then you find the probability of any of those options, which you end up with there is about a 75% probability that at least 7 of 10 seat occupants are in fact wearing seatbelts. Thank you. Okay, thanks, Al.